Question number 30. The radius of hydrogen atom in the ground state is 0.53 angstrom. The radius of lithium ion in similar state is. So the radius of hydrogen atom, we know that atomic number of hydrogen is 1. First shell contain 2 electrons. First shell contain only 1 electron. There is only 1 electron, so first shell contain 1 electron. First shell is n is equal to 1 shell or k shell. Second shell is n is equal to 2 shell or L shell. Okay. Now, in the case of lithium atomic number 3 configuration, first shell contain 2 electron, second shell contain 1 electron. Now, the radius of hydrogen atom in the ground state is 0.53 angstrom. The radius of lithium ion in a similar state, Li2 plus ion. So Li2 plus means we have to remove 2 electron, one from n is equal to 2 and one from n is equal to 1. So now lithium ion has only 1 electron. So we have to calculate radius of lithium ion in a similar state. So in hydrogen, there is only 1 electron, and that electron is in n is equal to 1. This is the ground state of hydrogen. Ground state. Ground state means its normal state. So in hydrogen atom, the ground state is if n is equal to 1, n is equal to 1 or k shall contain 1 electron. This is the ground state. Okay. Now lithium 2 plus, there is only 1 electron and that electron is present in n is equal to 1. So the radius of hydrogen atom in the ground state is 0.53 angstrom and the radius of lithium ion in the similar state. So in the similar state, that is n is equal to 1, that electron is present in n is equal to 1, we have to find the radius of lithium ion. Now we know the equation to calculate the radius of orbits. Rn is equal to 52.9 into n square by Z picometer. Now here answer is given in angstrom, so you can use radius equation in angstrom also. Okay, Rn is equal to, please wait, Rn is equal to 52 point, instead of 52.9 you can write 0.529 into n square by Z angstrom. Now this is the equation in angstrom. This is the equation to calculate radius in angstrom. This is the equation to calculate radius of orbits in angstrom. Okay, now this is the equation to calculate radius of orbits or energy levels in picometer. Now here answer is given in angstrom, so you can use this equation. So Rn is equal to, here n value is 1. We have to calculate radius of lithium ion and the electron is present in n is equal to 1. So shell is 1. So R1 is equal to 0.52 into n square by Z. That is 1 square by, now what is the atomic number of lithium? That is 3. Z means atomic number, so 3. So that is 0.52 divided by 3, which is equal to 0.17 angstrom. Now if you divide this by 3, if you divide 0.52 divided by 3, you will get 0.17 angstrom. Answer is option 3, 0.17 angstrom. I think it's clear. Moving on to next question. In a Bohr model of an atom, when an electron jumps from n is equal to 1 to n is equal to 3, how much energy will be emitted or absorbed? So here an electron is jumping from, an electron migrates from n is equal to 1 to n is equal to 3, right? An electron jumps from or migrates from n is equal to 1 to n is equal to 3. Now we have to calculate how much energy is absorbed. So this electron migrates to n is equal to 1 to n is equal to 3 by absorbing energy, right? It migrates to n is equal to 1 to n is equal to 3 by absorbing energy. It migrates from n is equal to 1 to n is equal to 3 by absorbing energy, energy. Right. So we have to calculate the amount of energy absorbed when an electron migrates from n is equal to 1 to n is equal to 3. So an electron will migrate from lower energy level to higher energy level by absorbing energy. So we have to calculate the amount of energy. Now, energy can be calculated by using this equation, minus 2.18 into 10 raised to minus 18 Z square by n square. This is the equation to calculate energy. Now, let the energy of first shell be E1. E1 is equal to minus 2.18 into 10 raised to minus 18 into Z square. That is here a Bohr model. Okay, in a Bohr model of atom, here atom is not given. Now in Bohr model, Bohr used hydrogen atom to explain this model. I think you remember the heading Bohr model for hydrogen atom. When we learned the theory, when we learned theory part of atomic structure, we learned in Bohr model, we learned Bohr model for hydrogen atom. Bohr proposed model for hydrogen atom. So in Bohr model, Bohr proposes model for hydrogen atom. That means here Z value is 1 because hydrogen atomic number 1. Here atom is not given. That means in a Bohr model of atom, here name of atom is not given. That means it is hydrogen because Bohr proposed this model for hydrogen atom. Now for hydrogen atom, Z value is equal to 1. So you'll get E1, first energy of electron in first shell. N is equal to 1 as minus 2.18 into 10 raised to minus 18 joules per atom into 1. Okay, atomic number 1 square by n value is also 1. Z square by n square joules per atom. Now, energy of electron in third shell is minus 2.18 into 10 raised to minus 18. Again, my atomic number 1 square divided by, and now n value is 3, so 3 square joules per atom. Now we have to calculate energy change. So delta E is equal to final energy minus initial energy, EF minus EI. Final energy minus initial energy. Here final energy is E3 and initial energy is E1. This is final. Electron is jumping from N1 to N3. So this is final and this is initial. So delta E is equal to E3 minus E1. Okay. So delta E is equal to final energy minus initial energy. E3 is minus 2.18 into 10 raised to minus 18. Okay. Okay. 1 square by 3 square. Right. Now E1 is minus 2.18 into 10 raised to minus 18, 1 square by 1 square. So I'm taking minus 2.18 into 10 raised to minus 18. Both of them have minus 2.18 into 10 raised to 18. So I'm taking minus 2.18 into 10 raised to minus 18 outside and taking the remaining part, that is 1 square by 3 square minus 1 square by 1 square. I think it's clear. Both of them have minus 2.18 into 10 raised to minus 18. So I'm taking minus 2.18 into 10 raised to 18 from both E3 and E1. Remaining 1 square by 3 square minus 1 square by 1 square. I think it's clear. I don't have space, so I'm writing here. Okay. Joules per atom. Okay. Now, delta E is equal to minus 2.18 into 10 raised to minus 18. Solving this, you will get 1 minus 3 square 9. That is 9 by 9 into 1. That is delta E is equal to, I'm writing the remaining part, I'm writing here. Delta E is equal to minus 2.18 into 10 raised to minus 18 joules per atom. Okay. Joules per atom into minus 8 by 9. 1 minus 9 minus 8 by 9 joules per atom. Now, here answer is given in ergs. So this joules is converted to ergs. How to convert joules to ergs? Joules converted to ergs by multiplying with 10 raised to 7 minus, okay. Joules convert to ergs by multiplying with 10 raised to 7. So 10 raised to 7. 10 raised to 7 ergs per atom. Now after multiplying, minus 2.18 into 10 raised to minus 18 into 8 into 10 raised to 7 divided by 9. After dividing and multiplying, you will get delta E is equal to, I'm writing the answer, you will get 1.93 into 10 raised to minus 11 ergs. 1.98 into 10 raised to minus 11 ergs. Or you can write, I'm taking this point to this side, so you'll get 0.193 into 10 raised to minus 10 ergs per atom. Ergs per atom. Answer option D. 0.193. Here 1.93 into 10 raised to minus 11. We got 1.93 into 10 raised to minus 11. I'm taking this point to this side. You will get 0.193 into 10 raised to minus 10 ergs per atom. Answer option 4. I think it's clear. Moving on to next question. Question number 64. The electronic configuration of gadolinium. Already you have studied the electronic configuration of gadolinium in D and F block. Okay, I think you know the configuration of gadolinium. Anyway, I'll show you gadolinium. Gadolinium atomic number 24. Sorry, 64. Now, first one is xenon. In each answer, xenon is the xenon atomic number 54. Now, 10 more electron remaining. 3, 3 plus 5, 8, 9, 10. 6, 7, 8, 9, 10. 8, 8, 9, 10, 19. This is not the right answer because 8 plus 2, 10, 10 plus 9, you will get 19 electron because that is not possible because gadolinium is having atomic number 64. Xenon is having atomic number 54. Now remaining 10 electron. 54 plus 10, 64. Here 54 plus 8 plus 9 plus 12. So you'll get 54 plus 10 is 64 plus 9, you will get 73. So this is not the right answer. And this one, xenon 54, 54 plus 7 plus 1 plus 2, that is 54 plus 10, 64. So 1, 2, 3. They contain 64 electrons. So I'm going to write the configuration gadolinium xenon 54. Now last shell, that is sixth shell, 6s. 6s contain 2 electrons. Last shell is 6s. Okay, gadolinium belongs to lanthanide series. There are 2 series in F block. There are 2 series. Gadolinium is present in this series, lanthanide series. Now, lanthanide series, last electron, they contain last shells were 6s, 5d, 4f. These are the last shell of lanthanides, lanthanoids. Now, for actinoids, last shell, this is actinoids. For actinoids, last shells were 7s, 6d, 5f. Now, if you know this, you can easily write the configuration. 6s, 5d, 4f for lanthanoids and 7s, 6d, 5f for actinoids. Now, gadolinium belongs to lanthanoid series. So, xenon 6s, 5d, 4f. Now 6s contain 2 electrons. Now usually 5d is vacant. So how many electrons are remaining? 8 electrons. So 54 plus 2, 56 plus 8, 64. But if you check, there is no answer like this. So this is wrong. Actually, d electron is always 0, d electron. While we filling F block element, d orbital is having 0 electron. That orbital is always vacant. So this is the right configuration. But here, F can occupy maximum of 14 electron. Now, if one electron migrates from here to here, then F block is half filled. Half filled are always stable. So exact configuration is xenon 4f7, 5d1, 6s2. Right answer, option 4. This is the right answer. Okay, I'll explain once more. Please listen carefully. Gadolinium. You should know in which series this gadolinium belongs to. Gadolinium belongs to lanthanide series. Now, for lanthanide series, their last shells were 6s, 5d, 4f. Last shell, penultimate shell, anti-penultimate shell. 6s, 5d, 4f. Last shell, penultimate shell, anti-penultimate shell. Now, for actinoids, last shell, penultimate shell, anti-penultimate shell were 7s, 6d, 5f. Now, gadolinium belongs to lanthanoid. So, xenon, their last shells were 6s, last shell, penultimate shell 5d, anti-penultimate shell 4f. Now, we have to fill the electron 54. Always in F block, S shall contain 2 electrons. S always contain 2 electrons. In lanthanoids or actinoids, S always contain 2 electrons. Now, remaining electrons are given in F orbital. So here remaining electron 8 electrons. So F orbital will be 8 electron. D will be always vacant. So we may expect a configuration like this. But the problem is here if F can accommodate maximum of 14 electron. So if we accommodate 7 electron, then it will have half filled arrangement. So instead of 8, we are filling only 7 electron and 1 electron is placed in 3D. Always D is vacant in lanthanides. D is vacant in lanthanides. But for gadolinium, due to get half-filled configuration. One electron is promoted to 3 D. So D is having one electron. This is the right configuration of gadolinium. I think it's clear. Moving on to next question. Question number 33. The ion that is isoelectronic with CO. Now CO contain how many electrons? 6 plus 8, 14 electron. CO is having 14 electrons. Now we have to find species which is isoelectronic with CO. That is a species having same number of electrons as that of CO. Cn minus. Now if you take Cn minus, Cn 6, nitrogen 7, and minus means one electron is added. So one more electron. One electron is added. Minus means one electron is added. So you'll get 6 plus 7 plus 1, that is 14 electron. So Cn minus having 14 electron. CO is having 14 electrons. Cn minus is also having 14. 6 plus nitrogen 7 minus means one more electron, you'll get 14. Now N2 plus. N2 is having 14 electron, plus means you have to remove one electron. So 14 minus 1 only 13 electron. Plus means you have to remove one electron. O2 minus. 1 oxygen 8 electron, 2 oxygen 16, minus means one more electron, that is 17 electron. N2 minus. Nitrogen 7 electron, 7, 2 nitrogen means 14 electron, one more minus means 14 plus 1. One negative charge means you have to add one more electron, that is 15 electron. So Cu is isoelectronic with Cn minus. I think it's clear. Question number 34. The Bohr orbit radius for hydrogen atom is approximately 0.53 angstrom. The radius of first excited state, that is N2, is equal to 2 orbital angstrom. So we have to calculate radius of second orbit. The radius of first excited state, that is second orbit, and is equal to 2. So for hydrogen, Z value is equal to 1, atomic number 1. Now we have to calculate the radius of second shell, okay, in angstrom. Now radius in angstrom is calculated using this formula, 0.52 into n square by Z angstrom. This is the equation in angstrom. To calculate radius, we can use this equation. So Rm is equal to, that is R. We have to calculate radius of second shell. So R2, second shell. The radius of first excited n is equal to 2, that is second shell. R2 is equal to 0.52 into 2 square by 1. Z value 1. For hydrogen, Z value is 1. That is 0.52 into 2 square 4 angstrom. And after doing this, you will get nearly, I'm writing the answer. I have done this answer. You get 2.08 angstrom or something. You will get 0.08 angstrom, which is nearly equal to 2.12. So answer is option 4. Okay, 4 2s are 8 and 5 4s are 20. You will get 2.08. Okay, which is nearly equal to 2.12. Answer option 4. I think it's clear. Next question, question number 35. Which of the following configuration is correct for ion? Now we know that ion, atomic number 26, configuration, atomic number 26, ion is having atomic number 26. Already taught you when we are discussing atomic structure, theory part. So already taught you in theory part, ion atomic number 26, configuration 1s2. Then after 1s we have to fill 2s, 2s2. After filling 2s we have to fill 2p, 2p6. After filling 2p, 3s, 3s2. Then 3p6. Then 4s2. Then 4s2, 4s2. So 2, 4, 10, 12, 18, 20. Now 3d, 6. This is the configuration of ion. Now usually before filling electron, 4s is having energy lesser than 3d. But if one electron is added to 3d, its energy gets reduced, and now 3d is having energy lower than 4s. If one electron is added before adding electron, 4s is having energy less than 3d. But when we place one electron, the energy of 3d will get reduced. So we can write, for after 4s you have to fill 3d, but after filling 3d, what happened? Energy of 3d get reduced. So you can write 3d 6. This is the exact configuration of ion. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. This is 4s. After filling 4s, we are filling 3d. But since when one electron is added to 3d, its energy is getting reduced than 4s. So 4s is filled. Then after that 3d is filled, but you have to write before this. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. I think it's clear. So 1s2, 2s2, 2p6, 3s2. This is not the right answer. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d5. Yeah. This is not the right answer. 3d5. 1s2, 2s2, 2p6, 3s2, 3p6, 3d5. No 4s. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. 3d6. This is the right answer, but they have not written this 3d before 4s because I don't know why they are not written. But actually, 3d, actually 4s is having lower energy than 3d. But if one electron is added to 3d, energy of 3d will be reduced than 4s. So you have to write like this: 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d is having one electron. Now the energy drops to 3d1. But here iron is having 6 electrons, so 3d6. If one electron is added to 3d, its energy is dropped. So answer is option 4. They have not written 3d before 4s. Anyway, this is the right answer. I think it's clear. I think it's clear. Moving on to question number 36. Which of the following has maximum number of unpaired electrons? N3 plus, Fe2 plus, Zn plus, Cu plus. Nitrogen. Atomic number 7. Configuration 1s2, 2s2, 2p3, right? Sorry, 2p3. 1, 2, 3. 2, 4, 5, 6, 7. N3 plus means we have to remove 3 electron. 1, we have to remove 3 electron. 1, 2, 3. 3 electrons are removed. Now, how many unpaired electrons are there? Maximum number of how many unpaired electrons are there? There are no unpaired electrons. All electrons, remaining all electrons are paired. 0 unpaired electron. Okay. Now, Fe2 plus. Iron. Atomic number 26. You can write argon. Argon means 18 electron. Then 4s2. 4s is filled first. 4s2. Then 3d5. Actually, 3d is coming after 4s, but when 3d is when one electron is filled in 3d, its energy is lowered. So we can write argon 4s2, then 3d. 1, 2, 3, 4. 3d. 1, 2, 3, 4, 5, 6, 18, 19, 20, 26. Okay. Fe2 plus means we have to remove 2 electrons. So 2 electrons are removed from 4s. Now how many unpaired electrons are there? 1, 2, 3, 4. 4 unpaired electrons. Now next one zinc. Zinc atomic number 30. You can write the same configuration: argon 18 electron, 4s2 and 3d. 3D 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. 18 plus 2, 20, 20 plus 10, 30. Now Zn2 plus means we have to remove 2 electrons. 2 electrons are removed from 4s. How many unpaired electrons? All electrons are paired. 0 unpaired electrons. 0 unpaired electrons. 0 unpaired electron. P-A-I-R-A-D. 0 unpaired electron. 0 P-A-I-R-E-D. Unpaired electrons. 0 unpaired. P-A-I-R-A-D. Okay, one more students. 0 P-A-I-R-E-D. Paired electrons. Now last one, copper. Copper atomic number 29. Now copper is having exceptional configuration. You remember that copper and chromium, they have an exceptional configuration. Argon 4s 3d. Atomic number 18. Here 4s is filled only 1 electron because copper is having exceptional configuration. Remaining 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. To get d orbital completely filled, 4s is filled partially. That is one electron is placed in 4s. Now Cu plus. Cu plus means one electron is removed. So how many unpaired electrons? 0 unpaired electron. So which of the following has maximum number of unpaired electrons? Fe2 plus is having maximum number of unpaired electrons, 4 electrons, 4 unpaired electrons. So answer option 2, Fe2 plus. I think it's clear. Moving on to the next question. The following quantum numbers are possible for how many orbitals? N is equal to 3, L is equal to 2, M is equal to 2 plus. Already we have done these questions. N is equal to 3 and L is equal to 2 means it is 3D orbital. Now 3D orbital, right? Okay. Now if L value is equal to 2, ML value is equal to -2, -1, 0, 1, 2. -2, -1, 0, 1, 2. So N3, this is 3D orbital, N value 3, N value 3, L value 2, and if L is equal to 2, M can have value -2 to +2, this -2 to +2. Now N3, L2, M plus 2, that is this orbital. N3, N3, L2, and ML value 2 plus 2. So the following quantum number are possible for how many orbitals? There is only one orbital with N3, L2, and ML value 2. So how many orbitals are there? Only one orbital. I think it's clear. Okay. I think it's clear. Only one orbital is there. N3, N3, L2, and ML value 2. There is only one orbital. So answer is option 1. Moving on to question number 38. The frequency of the radiation emitted when an electron flow from n is equal to 4 to n is equal to 1. So an electron is jumping, an electron is falling from n is equal to 4 to n is equal to 1. Right? Hydrogen atom will be. So we have to calculate the frequency of radiation emitted when an electron falls from n is equal to 4 to n is equal to 1 in hydrogen atom and will be answer. Now we can use two formulas to find the frequency of radiation emitted when electron jump from n is equal to 4 to n is equal to 1. There are two equations. Already this is discussed in line spectrum part. You can refer the video. Okay, if you want the theory again, you can refer the video. Already we have discussed how to calculate the amount of energy released when an electron jump from higher energy level to lower energy. We can use two formulas. Now here I am using this formula. Nu bar is equal to 1 by lambda is equal to RH into 1 by N1 square minus 1 by N2 square. I'm using this formula. Okay. So 1 by lambda is equal to, what is RH value? 109677 centimeter inverse. You remember that value. 109677 centimeter. That is RH, Rydberg constant. Now, N1 means to which shell the electron is jumping. This is N1. To which shell the electron is jumping. To which shell it is jumping to. Now, N2 means from which shell. This is N2. From which shell. From which shell. So, here N1 is 1 because the electron is jumping from 4 to 1. To which shell the electron is jumping. That is N1. So, 1 by 1 square minus 1 by N2 is from which level the electron is jumping. Fourth shell. So 1 by 1 square minus 1 by 4 square. So you'll get 1 by lambda is equal to 109677 into 4 square. 16 minus 1 by 16. Right. So 1 by lambda is equal to 109677 into 15 by 16. So this is 1 by lambda. So lambda is equal to 16 divided by 109677 into 50. Okay, 109677 into 50. Now we have to calculate frequency. What is the relation between frequency and wavelength? Nu is equal to C by lambda. So nu is equal to C is 3 into 10 raised to 8 meter per second. 3 into 10 raised to 8 meter per second. Okay, 3 into 10 raised to 8 meter per second divided by lambda. What is lambda value? 16 divided by 109677 into 50, right? Or you can write 3 into 10 raised to 8 divided by 16 into 109677 into 15. Now after doing this, you will get answer which is equal to, if you after doing this, you will get answer. Okay, you have to calculate this. I didn't calculate it, so I'm going to calculate the value. So answer is 3 into, I'm going to calculate the value. Answer will be equal to, so answer is you will get 3 into 1096 into 15 divided by 16. You will get nearly 308. You will get this value 308,466.56 into 10 raised to 8. Or you can take this point to this side, 1, 2, 3, 4, 5. That is 3 point. Okay. Okay. After multiplying, you will get 308,446 308,466.56 into 10 raised to 8. Okay. So you will get 3. I'm taking this point to this side. 1, 2, 3, 4, 5. So 3.08 into 10 raised to 8 into 10 raised to 5. You will get 8, 9, 10, 11, 12, 13. You will get 3.08 into 10 raised to 13 second inverse. So nu bar is equal to 1 by lambda is equal to RH into 1 by n1 square minus 1 by n2 square. Okay, so 1 by lambda is equal to 907677 into 1 by n square minus 1 by 4 square. So after doing this, you will get 4 square 16. 16 minus 1 by 16, you will get 15 by 16. That is, lambda is equal to 16 by 109677 into 15. Now, nu is equal to c by lambda. C is equal to 3 into 10 raised to 8 meter per second divided by. Okay, now there is one small mistake here. We got this in centimeter inverse. So first we have to convert this into meter inverse. So here answer is given. Here we got answer. Please wait, students. Here we got answer in centimeter inverse. Sorry, I forgot to write that. Here we got answer in centimeter inverse. So we have to convert this into meter inverse. How to convert centimeter inverse to meter? How to convert centimeter inverse to meter inverse? Multiplying with 10 raised to minus 2. So you have to multiply with 10 raised to minus 2. So you'll get meter inverse. Okay. So to this value, you have to multiply with 10 raised to minus 2. Okay. Now I'm taking 10 raised to, okay, 10 raised to minus 2. So you will get like this answer. You will get answer like this. 3.08 into 10 raised to minus 8, 10 raised to 8 into 10 raised to 5 divided by 10 raised to minus 2. Here, answer is, here we have to take this equation as in centimeter inverse. Okay, this answer is in centimeter inverse, but we took velocity of light in meter per second. So we have to multiply. To convert centimeter to meter, you have to multiply with 10 raised to minus 2. Okay, 10 raised to minus 2. So 3 into 10 raised to 8 into 109677 into 15. Okay, divide by 60. Now after doing, you will get 3. Okay, now there is also 10 raised to minus 2 is there. There is one 10 raised to minus 2. I'm taking this 10 raised to minus 2 to above. So it will become into 10 raised to 2. Okay, I forgot to write that. So you will get answer. You will get 3. I'm writing here 3.08 into 10 raised to 8 into 10 raised to 5 into 10 raised to 2. Here I forgot to write one 10 raised to minus 2 because here this equation is centimeter inverse and we took velocity of light in meter. So you have to convert centimeter inverse to meter inverse. Okay, now 3 into 10 raised to into 9, 109677 into 15 into 16 into 10 raised to minus 2. Okay. Now after solving, you'll get 3.08 into 10 raised to 8 into 10 raised to 5. And that is divided by 10 raised to minus 2. I'm taking this 10 raised to minus 2 above. So 3.08 into 10 raised to 8 into 10 raised to 5 into 10 raised to 2. You will get 3.08 into 10 raised to 50. Answer option 3. Answer option 3. I think it's clear. Okay, I forgot to write the centimeter inverse. That's why we got 3.08 into 10 raised to 30. 10 raised to 2 was missing. Actually, the 10 raised to 2 come from here. You have to convert centimeter to meter inverse. So you'll get 10 raised to minus 2 meter inverse. Okay, I think it's clear. Moving to next question, next part, next one. Okay. Question number 39. Which one of the following ion has electronic configuration argon 3d6? Argon 3d6. Argon 3d6. Okay, so cobalt. I'll start with option 1. Cobalt. Atomic number 27. Configuration argon 4s2 3d7. Now, cobalt 3 plus means we have to remove 2 electrons from 4s and 1 electron from 3d. 1 electron from 3d. Okay, 1 electron from 3d. You have to remove 1 electron from 3d. So you'll get, I'm removing 1 electron from 3d. Okay. So you'll get argon 3d6. So answer is option 1 itself. Cobalt atomic number 27. Configuration argon 4s2 3d7. 1, 2, 3, 4, 5, 6, 7. So cobalt 3 plus means we have to remove 3 electron, 2 electron from 4s and 1 electron from 3d. Now how many electrons are there in 3d? 1, 2, 3, 4, 5, 6. So answer option 1 CO3 plus. Moving on to last and final question. Which of the following is not among shortcoming of Bohr model? Not among shortcoming of Bohr model. Bohr model could not, so limitation of Bohr model, which of the following is not among shortcomings of Bohr model? That is limitation of Bohr model. Bohr theory could not account for the fine lines in atomic spectra. Already we have discussed in this theory part. Bohr model, there are 5 lines in hydrogen spectrum. They are known as spectral line. Now, if these lines are observed through a sophisticated instrument, each line is split into some small lines. This is known as fine spectra. If each line is observed through a sophisticated, a powerful instrument, you can see each line, Lyman, Balmer, Paschen, bracket, Fund, split into small line. That is known as fine lines or fine spectra. So Bohr model could not explain fine spectra. That is a limitation of Bohr model. So this one is correct. Here they are asked to which of the following is not limitation. Which one is not which one of the following is not the limitation of Bohr model. This is limitation of Bohr model. Bohr theory was unable to account for the splitting of spectra in the presence of magnetic field. Now, when we place the spectral line in magnetic field, each line will split to small lines. This is known as Zeeman effect. Bohr model could not explain Zeeman effect and Stark effect. Stark effect means if these lines are observed through electric field, each line split to form small lines. Okay, this is known as Stark effect. Bohr model could not explain Zeeman effect and Stark effect. So this one is also correct. Bohr theory failed for helium atom, right? Bohr theory could not explain line spectrum of helium. Bohr theory could explain line spectrum of hydrogen. It contained 1 electron. It could not explain helium, but it could explain line spectrum of helium plus. Helium plus contained 1 electron. Helium contained 2 electron. Helium plus contained 1 electron. It could not explain line spectrum of lithium, but it could explain line spectrum of lithium ion. Li2 plus ion, because these species, all of them have 1 electron. So Bohr theory could explain line spectrum of 1 electron species, hydrogen, He plus, Li2 plus, etc., but could not explain line spectrum of more than 1 electron. More than 1 electron. So Bohr theory failed to explain helium atom. Bohr theory is used to explain hydrogen atom. It is used to explain hydrogen atom. Bohr theory for or Bohr model for hydrogen atom. Bohr model is used to explain model of hydrogen atom, not for other atoms. So it failed to explain helium atom. It does not give information about energy. This is wrong. It give Bohr model gave the information about energy levels, right? First cell is having energy E1, second cell is having energy E2, third cell is having energy E3, etc. So he gave energy of orbits, and he gave an equation to calculate energy. En is equal to minus 2.18 into 10 raised to minus 18 Z square by N square joules per atom. So his model explained he could explain energy of each orbits. Okay, but last option says that it does not give any information about energy. That is wrong. His model could explain energy of each orbits using this formula. En is equal to minus 2.18 into 10 raised to minus 18 z square by n square. I think it's clear. So we discussed nearly 40 questions. I think all the questions are clear. So students, so I'm winding up. I'm going to winding up the class. So thank you, thank you, thank you.